All right, so in this lesson, we're going to explore through construction whether or not a triangle can be determined given certain parts. And so again, for this lesson, I've included 6 different demonstrations of figures that we're going to construct either throughout the lesson or in the homework. So to launch says use your construction tools to draw one acute angle on 2 segments and duplicate these 3 elements to construct a triangle. And so draw 2 random segments and then an angle. And then you're basically going to go ahead and combine these to draw a triangle. And so one of the simplest ways to do it would just be to swing an arc from here to here, and then keep the compass setting the same and swing the same arc, or right there. And then have an arc from here to here, come over here, swing an arc. And so now you have the same angle, and just go ahead and connect them like that. There we go. Okay, now is it possible to make another triangle that is not congruent to the first? And go ahead and try that. All right, now there's art that is perhaps the ultimate success story in geometric constructions. These are going to be very rich with Gothic art, and they knew how to use geometric constructions to make their amazing buildings here. And once you know the basic constructions, you too can solve intricate geometric design problems. For example, how would you construct the circle tangent to the 3 Gothic arches shown in the diagram below left, or create a design similar to one of the Islamic designs below right? You will get a chance in your exercise in this lesson. So with your knowledge of compass and straight edge constructions, you can also discover more of the properties of Euclidean geometry. You know how to duplicate segments and angles with compass and straight edge. Given a triangle, you can use these constructions to duplicate a triangle by copying each segment and angle. Can you construct a triangle if you are given the parts separately? Would you need all 6 parts, 3 segments and 3 angles to construct a triangle? So let's go ahead and consider the case here. So let's construct a triangle given 3 segments. How many different size triangles can be drawn here? And so in this case, I'm going to go up to one of the video that says construct a triangle given 3 sides. And so let's go ahead and see. So the first step, we're going to start with 3 segments here, and then go ahead and draw a random point, measure AB, and swing an arc. And make point B somewhere on that arc, and then find the width of AC and swing an arc from point A, and then find the width of BC and swing an arc from point B, and you have your triangle. Okay, so I'll go ahead and finish it up. And there we go. So run through that one more time. So you have 3 segments, random point, measure AB, swing an arc, and put point B somewhere on there, measure A to C, swing an arc, and then measure B to C, swing an arc, label point C, connect the dots. All right, so now there's that. Then we'll go back to the lesson here. Okay, so now it kind of shows you here how to do that, where you have A to C, and then you swing an arc from point C, and then swing an arc from point A, and where they intersect, you have your triangle. And the construction on the previous page that you see here, the segment lengths determine where the arcs intersect, and once the triangle closes, At the intersection of the arcs, the angles are determined too. So the lengths of the segments affect the size of the angles. So there are other ways to construct triangle ABC. For example, you could draw arcs AC and point B below arc AC and so on and so forth. But only one size of triangle can be drawn with the given segments. And if that's true, we say the triangle is determined. So if a triangle is determined, there's only one size of triangle that can be drawn with the given segments. What about if you have three angles? So for this one, we're going to use actually patty paper to do it. So if you duplicate each angle on patty paper, and you just duplicate A and duplicate B and kind of move it around, you can see that there are many different sizes of triangles that you could make with angles A and B. And the third angle up here, of course, will always be angle C. Okay. So because a triangle has a total of 6 parts, there are several combinations of segments and angles that may or may not determine a triangle. Having 1 or 2 parts given is not enough to determine a triangle. Is having 3 parts enough? That answer depends on the combination. In the exercises, you will construct triangles and quadrilaterals with various combinations of parts given. All right, so here we go. Based on your constructions, what determines a triangle? 3 sides or 3 angles or both? Well, based on our construction, 3 sides does, not 3 angles. Okay. Extra example, go ahead and draw a segment GH and construct an isosceles right triangle with each leg equal to 1/2 GH. Okay. So let's go ahead and do that. Go ahead and draw a segment GH. And here is GH. And we're going to construct a leg equal to 1/2 GH. So let's go ahead and do perpendicular bisector. So swing an arc from G, swing an arc from H. And then if I did it right, which I didn't because I don't have a compass, but if I did do it right, the line would be the perpendicular bisector of it. And I can probably try to do a little bit better job. You connect the points, which should be 90 when you do it. All right, so you have your little thing here, and now you know that the distance from this point to H and G are equal. So we'll call this point A. That's a bisector. So AH, this is 1/2 GH. And if I swing an arc from A to H, and then come up here and swing the same arc, now that's also the same. And all I need to do now is connect those points, and I have an isosceles right triangle. Boom. There we go. And that's kind of what they show you here. Okay. Closing question. In the examples, you found that 3 sides can determine a triangle, while 3 angles do not. Construct 2 congruent triangles from a mixture of sides and angles using the 3 parts. Describe what you did. And so one example of this would be kind of like in the homework, where it says construct a triangle from 1 angle and 2 segments, or from 2 angles and 1 segment. Those are the kind of things that you're going to explore in this question. There's actually at the top of the lesson here, they have a case of a triangle with 3 sides, triangle with 2 sides and included angle, and 2 sides and not included angle, and 2 sides and an included angle. And so here's this one, ASA. So this is 2 angles and an included side. So let me actually This link is actually needs to get fixed. Okay. There we go. And then this one should be SAS. There we go. Okay. Beautiful. So that goes over the different constructions. So let's go back here. So here's ASA. It's going to run you through if you have two angles and a side, an included side. How do you do that? We're going to swing an arc from A to B, label point B, and draw that. And then duplicate angle A using angle duplication. And then duplicate angle B using angle duplication. There you go. And you're done. If you have an SAS triangle, it's two sides and an included angle. Start with a random line, and we're going to duplicate AB. And then duplicate angle A. And then go ahead and duplicate, and then swing an arc from A to C. Now you have point C, you're done. Cool. Okay, so that's kind of how to do the closing question, different constructions, different combinations of stuff. And so that will help you with the homework here. All right, that concludes lesson 3.6.